relation is a function. There are a few different ways that we can show a relation. One of them is a set of ordered pairs. So let's look at an example of ordered pair 2, 3, negative 1, 5, and 6, 7. Now, in order for this relation to be a function, we are only allowed one x value per y value, or one domain per our range, or we could also say one input for output. So talking about a domain and range, we have an ordered pair, which is the x-coordinate, y-coordinate, always written x, y. So our first number in our ordered pair is our x's, our domain. So in this case, it's 2, negative 1, and 6. Since this x does not repeat anywhere, yes, this will be a function. So all we have to have is not the x's repeating for it to be a function. To write the domain, we write it as a set from least to greatest, and we would never repeat a value. Even if it wasn't a function, we could still write our domain. So in this case, my domain here, my lowest number is negative 1, then 2, and then 6. So that's my set of my domain. Now the range is the y values. So the other number in my ordered pair, the y value, is called my range. We have 3, 5, and 7. And we would also write this in a set from least to greatest, 3, 5, and 7. So here, given a set of ordered pairs, it is a function if the x does not repeat. The domain, which are my x values, the inputs we call them as well, we would write them least to greatest, no repeats. So in this case, the set of the domain is negative 1, 2, and 6, where my range is 3, 5, and 7, because range refers to the y values. There are other ways we could also represent a relation. One of the other ways we have this is in a graphic organizer, and it kind of looks like two ovals. And maybe we're given a couple numbers here, maybe negative 1 and 5, and maybe let's go with 2, 3, 4. And then they'll have these arrows connecting them. So in this case, the first oval is always our x values, our domain. Our second oval here is our y's. These are my x's, here are my y's. But notice what happens here. We have this 5 going to two different numbers. So this would be like the ordered pair 5, 2, and the ordered pair 5, 3. And then, of course, our last one there would be negative 1, 4. Well, that's no good. If I was looking again up here and looking at my x values, I see that my 5 repeated. So in this example, no, this cannot be a function. We could still write the domain and range, though. So here, my domain, and it's already from least to greatest, is negative 1 and 5. We would not write two 5s. We never repeat in our set of domain or range. And my range is 2, 3, 4. So again, you are a function if your x value does not repeat. There are two other ways we can represent relations. We can be given a graph, or we could be given a table. So let's look at a table. So in this table, we have our x, we have our y. And usually a table will go in order from least to greatest. Now in this case, we look at my x values, my domain, negative 1, 0, and 1, and my range, which is all 5. So when I'm writing my domain and range, again, it's already written from least to greatest there. Domain is negative 1, 0, and 1. And my range here would just be a 5. I would not write 3 5s. I would not repeat. So my range is 5. But is it a function? Well, if we look, my x here, negative 1 goes to 5, my 0 goes to 5, and my 1 goes to 5. My x values do not repeat. So yes, this is a function. Although they go to the same range, again, the rule to be a function is the x's do not repeat. So this one works. And the last example here, let's take a look at a set of ordered pairs. So say we have my x, y coordinate graph, And let me put some markings in here. Let's go by 3 here. And let's put some ordered pairs. Okay, so I see these 5 ordered pairs. Now, the first we want to talk about with my domain and my range. Now, my domain are my x values. So I'm going to read going across on my x values. So coming across from the left going to the right, I see that I have one ordered pair here, one little ordered pair that's going to have an x coordinate of -2. If I keep on going, I'm at 0, and they're both here. I have 2 at 0. Keep going, I have an ordered pair at the x value 1, and then a 3. Now when I'm looking at my range, I want to look at my y number line here, my y piece. So going from low to high. Here, I have a point at -3 on the y-axis. Then this is 0. I have 2 points on the 0, and then up at 1. So I wrote that down. So my domain, again, would be the x coordinate. And you could write out these ordered pairs. So for example, this ordered pair is -2, 0. This ordered pair is 0, -3. I have a 0, 1. I have a 1, 0. And I have a 3, 1. And we can make sure we wrote this right with my domain. So least to greatest, no repeats. -2, 0, 1, and 3. -2, 0, 1, and 3. Range, I have 0, -3, 1, 0, 1. So I should have -3, 0, and 1. -3, 0, and 1. It's easy when you look at it from low to high to name it least to greatest. Now, to answer the question, is it a function? So we have 2 ways we can look at this when we're given a graph. We can, of course, make sure our domain does not repeat. But we do have this instance here where I have an x going to a -3 and an x going to a 1. So no, it is not going to be a function. We also have what's called the vertical line test. And if I was to imagine a bunch of vertical lines here on my graph, if I had an infinite amount of vertical lines going through, if a vertical line hits more than one point at a time, so see how it's hitting this point and this point on this vertical line? We would say that fails the vertical line test. So that would also be another reason why, no, it is not a function. If I wanted to talk about other graphs, quickly with the vertical line test. If I had a circle graph, this would fail my vertical line test, an infinite amount of spots. I see how it hits multiple spots on that vertical line. So this would be no, not a function. But if I had a graph such as, let's look at my cubic function, it would pass the vertical line test. There's no spot where a vertical line hits more than once. So this one is a function.